I'm Tom Armitage, Senior Technical Writer at Maptiler and Honorary Fellow at the University of Edinburgh School of Geosciences. And I'm going to spend the next 20 minutes talking about hill shading in QGIS. Bit dull, sorry. Okay, back to my usual style. So, today we're going to take a look at the various ways in which you can use terrain data in the form of digital terrain models or digital surface models to create beautiful hill shading effects in your maps. We'll look at how this can be done on global data pulled down from the web, or on more detailed data from your local hard drives. And finally, we'll add satellite data, throw in a few other techniques, and pull it all together using blend modes, hence return of the blend modes. Sorry, enough of that, silly. Okay, so before I get started, the whole shtick there, back in 2016, I started doing these silly Star Wars themed talks. I finally get to complete the trilogy because I did one in 2018, and now this one I can put this to bed and move on to doing more sensible talks. But let's carry on with today. So what is hill shading? So essentially, it's using GIS to work out where the shadows would lie in a real world scenario, and then adding these in as an extra layer into the map as shading. So it makes the sort of other features, hills, things like that, stand out and look 3D. So when it's used well, it makes maps more atmospheric. It lends some realism and makes maps come alive for the viewer. So you can see the land. It's not just some abstract features. You get to understand why the roads go where they go, why the rivers go where they go, because you've got that context. And when it's used well, I really strongly believe that to do it well, you have to blend equal parts science and art. And then you create something that's captivating, illuminating, and it's showing the viewer some new information that makes them want to engage more with the map that you've made. Okay, so where to begin? Let's do some basic training. First of all, we need some data. So I'm going to use the Maptiler plugin for QGIS. It's got this terrain RGB data in there that's global coverage. There's even a separate layer for the ocean bathymetry in there too. The plugin's free. It's open source as well, so you can contribute to making it better if you want. The plugin works with your free Maptiler account, so you just need to put your API key in there. So you get access to all these global data layers. To do that, once you've got the plugin installed, the API key set, just go into the QGIS browser, double click on Maptiler. You get these layers off the bat there, but you can also dig in and get any layer that you've got in your QGIS account. You can see there's the terrain, double click there, and instantly global terrain data, 30-meter resolution, and ocean bathymetry as well. Now, thanks to the work that we got Lutra Consulting to do from Maptiler, these layers are brought in as XYZ tiles. So vector layers and XYZ raster layers. And the beauty of that is you get to use them like they were layers in QGIS, not just pictures that you're streaming in from the internet like a WMZ or something like that. So that means once you've got the terrain RGB data in, you can just use the drop-down menu to style that as hill shading. One simple move, ta-da, done. Which is really, really great. But this looks terrible. And that's the thing with hill shading, that you actually need to put it over some other data for it actually to make any kind of sense. So, and the brilliant thing, QGIS has had these blend modes for years now. There's not a hint of transparency anymore. It's just the blend modes to merge these into the layers below without all of that fuzziness and loss of detail that you get with transparency. So let's zoom in on the Lake District. We've got the terrain RGB just with the color ramp on there, so height, altitude, showing different colors, and then we can just put those the terrain model over the top there, blend it in, and boom, straight away, hill shading on your terrain data. Brilliant. I can go home. Done. Okay, we can do better than this, definitely. Thank you. So just by tweaking a few of the settings, you can suddenly make that look an awful lot better. You can change the Z factor to 1.5. That makes makes the terrain more extreme. 1.5 on the height, so it's a little bit more extreme. Really brings things out. This is essential if you've got quite a flat area. It's not very hilly. Not really necessary in the Lake District, but it's a good thing to know about. There's the multi-directional. This is fantastic. This really elevates your hillshade. You're not just taking that sun coming from one side and casting shadows on the map. It's basically taking into account the whole of the sky. Light doesn't just come from the sun. On a cloudy day, it's not a point source. It's coming from all around in the sky. And that's what the multi-directional do. It adds that ambient light coming from other sources and just adds some realism. We're using the multiply blend mode, so it's darkening the shadows, but it can over darken stuff. So I've tweaked the brightness up there to 60, but increasing the brightness can wash out some of the detail. So tweak the contrast up to go along with that. And sorry for those at the back, right down at the bottom, there's this little tick box called early resampling. Now, when you're bringing in layers from the web, you don't get that resampling. That basically stops it going all blocky when you zoom in and you can see the 30-meter pixels. So by ticking the early resampling, that resampling is done before it's applied to the map, so it actually works. It doesn't work with web layers that when you change from nearest neighbor to bilinear or whatever else it is in the resampling. So there we go. We have that. And so, yeah, I got all of these values basically through trial and error. There's nothing particularly scientific about it. This stuff works on satellite data too. The problem with this is the mix of colors, light and dark places, makes the effect harder to see. So in general, it kind of over darkens the map. So there you can see that's added the hillshade with the multiply blend mode. We've still got the brightness up, we've got the contrast up, but it's quite difficult to see. That's the nature of using some satellite data and aerial imagery. But if we use an overlay blend mode instead of the multiply, now quickly I'll try and do a bit of theory here. So a multiply blend mode is like basically taking two slides in a projector and shining one light through them. So it really darkens down the darkness. And the opposite of that is the screen blend mode. And that's like taking two projectors, each with a slide in, and shining them on the same wall and getting the brightness multiplied. So with the overlay, it does both of these things. So the bright bits get brighter, the dark bits get darker, and you get a lot more contrast in there. So that looks really, really, really good. Now you can go one level extra, and that's using the hard light blend mode. And that's just it really amplifies the effect even more. But it gives it this weird sort of plastic look. I quite like it. It reminds me of those maps you used to get in the outdoor shops in the Lake District and everything like that. But yeah, so there you go. But there is a note to this. This is quite zoomed out. If you're doing hill shading on aerial imagery where you've got deep shadows in it already, it just tends to look rubbish, particularly if the time of day and the angle of the sun that you've chosen for your hill shading are completely different. You end up, it just looks a mess. So not so bad. This is, I think this is aerial imagery, but quite zoomed out. Certainly with the satellite imagery, you're doing sort of mountain ranges and things like that. Maptiler satellite imagery is averaged different times of day, different times of year, just to remove all the clouds from it and things like that. So it works very well on that because there's a lot less interference from real shadows. So where does that leave us? We've got a tool that's great for bringing maps to life. Look how much easier it is to see the Highland boundary fault when we've put that blend mode on there. And we've got a layer that we can insert into any map to show the texture of the surface there. Outside of QGIS, we've got these layers that you can add into Leaflet, Open Layers, Map Libre, things like that. You can call on these pre-made hill shading layers to put into your custom cartography, and it's also embedded in some of the Maptiler ready-to-use maps. This is outdoor, winter with the ski slopes. And we've got this hand-drawn hill shade layer. It's a lot more artistic, draws on a lot of the inspiration from the legendary Swiss cartographer Eduard Imhoff, famous for his hill shading on Swiss topo maps. But let's go a little bit deeper now, shall we? Because I've talked about using local data, and this lets you get down to these sort of 25 centimeter per pixel layers. So this is Environment Agency 25 centimeter digital surface model with all the MacGuffin that's going on, the trees, the cars, and everything like that. So we can use that hillshade that we just same parameters, and you can start to see, you can see all like the cars, the people walking along the promenade, things like that. It's not bad, but I'd like to introduce you to the Relief Visualization Toolbox. So this is a plugin for QGIS. It's a plugin for other things as well, actually, but it creates all these weird and wonderful layers that just add loads of extra information. Things like sky view factor, openness, slope gradient, all of these things, you can create them as individual layers or this is just one of the presets that I really like, the archaeological. It'll blend them all together for you to create one, or you can take them out individually. Let's go through a few of these. So sky view factor, that basically assigns each point a value based on how much sky you can see from that point. So you can see in between the buildings really dark, tops of buses and things that stand out get really bright. We've also got the slope. Obviously, if there's quite a steep slope facing the angle of the sun coming in, it's going to be really bright. If it's lower, it's less bright. If it's opposite, then it's going to be dark. Then we've got openness. It's a sort of a more like sky view factor, but it's basically how much does it stand out or sit back in the general landscape. A lot less detailed than the sky view factor, but it just adds a little more nuance to your maps. And then it adds in a regular hillshade, unidirectional, because this is where the sun's coming from. You've got the sky view and the openness doing the ambient light. Then you've got the actual hillshade, the slope, and then when you blend them all together with the blend modes, you get something that's just really, really clear, really great. You can see details, the high tide line on the beach, the waves in the sea, people walking on the promenade, everything gets so much more detail. It looks really, just brings it to life. Let's jump over to Edinburgh. This is Holyrood Park. This is using the normal hill shading with the settings. And then this is the relief visualization. The texture of the trees, the grass, everything looks so much more realistic. You can even see the people queuing at the ice cream van there. And sorry, again at the back, but down in this bottom corner is the venue from 2019's Phosphor UK as well. So really, really cool. But yes, some weird artifacts. You get these like sparkle lines around. I guess that's from the multi-directional and really sort of turning up to 11. But this is actually designed for picking out elements in the landscape for archaeologists. You know, where's that barrow? Where's that burial ground? So that's why it's a bit overblown. But yeah, you can get really artistic now with these sorts of things. So this is quite a flat, dull aerial image of the same place. We can add in that hillshade that up from the RVT, the archaeological thing, with a blend mode. Then we can start drawing inspiration from a few other cartographers knocking around. John Nelson, as always, he's done some great stuff. This is adding some atmospheric perspective. So it's using that color ramp altitude, but sort of demystifying it away so it's really transparent in the mid levels, but where the low-lying ground is, you can bring it in so it gives this sort of green haze where the land is further away, and then you can also bring in the white bright bits on the highest land and pick out the peaks and brighten these things up. And so now you've got like something that's between like an artist's drawing and an accurate aerial photo, but it's really engaging. It's easy to understand. You've got the context from the photo, and you've got the extra detail from the hill shading, and it's kind of giving you more information than the surface model or the imagery. So yeah, fantastic. So I might have given the impression that it's actually better to use local data than the online stuff, but actually, if you get a bit creative, you can't bring in those things like sky view factor. That needs to be processed on data on your thing, but you can start mixing things together and bring in some of that Edward Imhoff's other thing. He used to use color in his hill shade, so coloring of the hill shading rather than just light and dark. So this is satellite imagery for where I live. Sorry, minor flex there. It's really beautiful. And I've overlaid on top of this 5 different layers. So hill shading, unidirectional, but from 3 slightly different angles using 3 different colors, red, blue, and green. And then blend them together, and it's just different. There's something different about it. It's just got a bit more interest to it, and it looks obviously red, blue, and green together will make the white light and the dark shadow, but there's some more detail and more nuance to it, and then add in the atmospheric perspective, and then on top of that, just bring in another final layer of hillshade, but with the contrast and the Z factor ramped up to 11, and what do we get? We get something I just really love this. So I'm really pleased with the result, and it's got lots of impact, and of course you can use this anywhere in the world, because this is just basically 6 layers straight from the Maptiler plugin. So you can zoom and pan around anywhere in the world, and you can have this kind of hill shading effect. Obviously, you do need to tweak that color ramp that's on the atmospheric perspective. This is set so that the lowest point and the highest point are good for this area. If you took this to the Himalayas, you need to do a different stretch on the color ramp there. But that's the only change you need to do as you move around the whole of the world. So just finally, to end with, a quick note that we're working on a lot of these sort of techniques inside the web-based map design tool for Maptiler, so that you can have all of these maps online using our SDK, which is based on MapLibre, that's the open source. So I hope you've got something from that journey through Hillshades. They're well worth experimenting with, using the online data or the local data. And I hope that this lets you build some maps with some extra impact. One last final little note as well, that Maptiler's user conference is coming up on the 21st of October. We've got an exciting afternoon of talks and panel sessions given by the Maptiler team and some of our users. So I hope you really can make it along to that. There is one particular thing that will be of great interest to us as Phos4G people, a little special announcement towards the end of the conference. I can't really say much more, but yes, there's this foundation which will benefit open source projects, actually financially benefit for open source projects. But you'll need to come along to the conference to find out exactly what that means. Join it online. You can just either scan the QR code, go to the page, just go to the Maptiler homepage. There's a banner on there. There's all over our social media. So thank you very much for listening. May the FOSS be with you. And has anyone got any questions?
Yeah, I work in marine space, and I'm fascinated because I've actually been using the Maptiler plugin. Amazing, and just to point out that the QGIS model moved to authentication database, which gave me some issues. The password, the key is stored in the authentication database. But anyway, application to the marine environment with this Hillshade, how would this be appropriate?
So I forgot to say, can you repeat the question for the recording?
So I guess the crux of that, the application of the hill shading in the marine environment, it basically works in the same way. So you can use that relief visualization toolbox, or you can use the hill shading techniques in the marine environment. There's great color ramps in there as well for the bathymetry. So yeah, you will find, looking at the data though, it's very patchy, and you get these weird effects where, you know, they've been looking for something on the seabed and it's really highly detailed, and then there's other places where it's just reliant on much more generic information. So even in the bathymetry model there, you can see where they were searching for planes and things that have gone down with these crisscross patterns going everywhere. But yeah, the hill shading works as well as it does on the terrain for under the water.
It's very valuable because a lot of the British waters are shallow seas, so we go off, away from Britain, we drop down to the deeper. So to bring out detail in shallow waters, that's some of the challenges on the less topographically intense terrain. So yeah, I'm going to play with this.
Very good, thank you. Yeah.
Relief visualization toolkit algorithms are slow. Have you found there's issues with how long it takes?
Yeah, so that's the question, is the relief visualization toolbox algorithms are slow. Yes, they are very slow. Yeah, I basically, it's a case of set them running, go make a cup of tea, have a biscuit, walk the dog, pick the kids up from school. Oh, it's finished, hey.
As a follow-up to that, then, that was a bit of a leading question. Would there be any interest in algorithms moved over to the GPU and have the GPU processed relatively quickly.
That's a very, very interesting thought, and probably something that we could maybe take up. The developers, I think, are they University of Ljubljana? I think something like that. But I know there are versions for other software. It's not just in QGIS. So
they're originally written in Java, I think, or something like that. That's another leading question. Basically, so I've come from a computer games background, so I'm used to writing GPU shaders and things like that. And I've already done some work on writing hill shading, funny enough, is running on the GPU, so you can do it all in real time. So I'd like to talk.
This is good. Yeah, we're getting offers of help to do this work potentially, or contribute to it. So that's fantastic. I really would love to see that, because it is quite slow, and hopefully we can make it quicker. Thank you.
So just a specific question about the terrain data on your map of when we saw the UK at the very beginning. The fens were covered in water in Norfolk, Cambridgeshire, that sort of thing. Is that something to do with the data? What's going on there?
Basically, the question is about the fens being underwater on the map. That's because that's their altitude. They are largely very, very close to some areas below sea level. So this comes then with separating out that's done on a single color ramp, ocean and land. You'll find that happens. Netherlands is probably quite bad for this as well. My suggestion on that is to separate your color ramps, your terrain and your ocean, and not to have anything that goes blue for your terrain color ramp, and put that over the top of your ocean bathymetry color ramp, which handles the blues. So yeah, that you see that there because it's a single, and it goes from minus 10,000 to plus 10,000 to do Mariana Trench to the top of Everest. But yes, this happens a lot, and it's in all the terrain data. I think even Ordnance Survey terrain data. There's this hole there, and you've got to get creative with your layering and your color ramps to avoid these issues. Definitely.
Cool. Thank you.
A couple of questions in the middle there, but we are running short on time, so keep them short.
Do you have any of this written up? Because it was great having it here. By the time we get back to QGIS, I'll have forgotten it all. So.
Do I have anything do I have this written up? I did, and then my blog got deleted due to an expired credit card and a spam trap being overzealous with messages from my service provider. So not at the moment, not really. I can probably dig out, get in touch. I think I have a practical workshop from Phos4G in Florence that covers a bit of this. The slides will be available. You may have noticed there's no text on them. So, but there are some numbers and things like that. So maybe you can figure it out. Let me know, and I will send you a PDF of the workshop from Florence.
And it was yours quick.
Yeah, that was my question really about documentation. I've never found any documentation on this stuff. I didn't think it has, but basically you're my source of truth.
The relief visualization. Question more documentation. Relief Visualization Toolbox has a website outside of QGIS, not on the plugins or anything. They have their own website, and there's a lot of information there that you can, certainly on those things like sky view factor and all this kind of stuff. So you can look up these things and get more information about that. But making the settings in QGIS, again, yeah, I can send you some old presentations and workshops on those.
Okay.
The
Thank you.
docs has an explanation on the blend modes as well. That's actually makes it quite obvious what's going on.
Yes, yeah. That's not too bad at all. Yeah.
Okay,
Great. Thank you very much.